Next up, we want to look at using Vlookup. It provides a very convenient way to grab data from a digital table that you might have for various engineering purposes. So here we're going to demonstrate it with vertices and their XY coordinates. You could also do this to look up prices for an estimation that you're putting together for a construction project or many other applications as well. We'll look at one other one by the time this video is over. So I have a series of vertices and their X and Y coordinates, and so this is a vertical table because each item is spread across one row. So a given item can be found in a row and all the other properties of that item are in successive columns here. So what I have down here is a box for a particular vertex. So if I wanted to look for vertex 4, I want to return the X and the Y coordinates automatically without having to look for them in a table and then type them into a cell. So we're going to use the Vlookup function for that. So it's equals Vlookup, and once you have it, you can just hit tab for the autocomplete again. Then we're going to key off a lookup value and then a table array and then return the column that we want and then range lookup, which I'll explain in a little bit. But the key that I'm going to look for in my table is 4. So the keys have to show up in the leftmost column of your table. So it's going to look for the key of 4 in this table, and then it's going to return whatever column that I ask it for. So the table is a range of cells, and since this table doesn't move at all, I'm going to lock it with the F4 key, and you'll see it locks the top left and bottom right. The third argument is the column, so for the X I want the second column because the first column in a table is always going to be the lookup key. And then I'm going to get the second, and then the last argument is whether you want an approximate match or an exact match. So most of the time for a lot of engineering purposes we want an exact match, so I only want to return the values if it finds the key that I'm looking for. So I'll type in false. So you can see it grabbed 2.48, which is from this table, and if I update this to maybe vertex 6, it's going to grab negative 0.29. We can do something similar for Y, so it's equals Vlookup of the vertex that I'm looking for in that table, and again I'm going to lock it, and then this time I want column 3 and again false. So you can see now this is a great way to grab data from a table automatically, and then you can use that data for successive calculations. An application here is looking at the centroid of a triangle. So if we have 3 vertices from the table above, what I want to do is use a scratch table to find the coordinates and then locate the centroid. So the centroid of any triangle in a plane is going to be equal to the average of the coordinates. So I already have a formula that'll grab the vertices from over here in the yellow boxes. So I just need to fill out this table with another formula that's very similar. So it's equals Vlookup of my ID and that same exact table. So I'm going to lock it. And then for the X I want column 2 and again false. Here's another little trick. If I lock the column, I can just copy this over and you see that column is maintained with the vertex, and I can change this directly to 3. And then once I have those, I'll copy them down, and you can see the plot over here is already set up to plot that. And then to finish this off, I'll just use the average formula to return the average of the X's, and then I can use relative referencing and just copy that over again to get the Y's, and it'll plot it as a little green dot here. The last bit is obtaining data from the Aisc table. So this is going to be useful in a steel design class. So I've grabbed the electronic database form from the Aisc website, and you'll see it's a very large table, and it has the manual labels for the shapes, and then it has a bunch of the properties that you would be using in structural design calculations. So the ones of interest that I want to grab are the area and the depth, and then I'm going to compute the weight so that we can see where these shape names come from. So the area itself is going to come from a table that's much larger than the one I have highlighted, but the labels are in the leftmost column. So this is column 1, this is 2, this is 3, and this is 4. So the area would be in column 4 of this table, and then the depth is right next to it in column 5. So taking a look at that, it would be, once again, the Vlookup formula, so equals Vlookup of the shape name, and now I'm going to look for the table, which is on another worksheet. So I'm going to select this entire table using Control Shift and the arrow keys, and then I'm going to switch back over, and you can see it kind of tried to add the sheet name here, so we'll get rid of that because all I need is the column. And recall the area comes from column 4, and then false for an exact match, and it pulls the area from that table. So taking a closer look at this formula, here's the lookup key, here is the table, and this is actually a reference to another worksheet. So it's referring to the database space v14.0 worksheet. So it's in single quotes, and then that's followed by an exclamation point. So this tells it, go look in another worksheet and then look at these cells. So this table is not going to move, so I'm going to make sure I lock that, and then again it was pulling it from column 4. So again, I'll lock the column, copy this over, and then change this to column 5 so I can return the depths. And then once I have that, I'll copy it down so I can get the shapes for W12 by 14, 10 by 60, and a 10 by 12. Now the weight per linear foot is going to be computed as the area times 12 inches per foot times the density of steel. The density of steel is approximately 0.2834 pounds per cubic inch. So I have the area in square inches. So I'm going to take the area times 12 inches per foot times 0.2834 pounds per cubic foot. And then I'll copy that down. And now you'll notice the shape name, the first number of a W shape in the Aisc table is the approximate depth. So here we have about 12. For the W12 by 14, it's just under 12, 11.9. And then the second number ends up being the weight per linear foot. So you can look at a shape and know the approximate depth as well as the weight per linear foot, which is quite useful when sizing up members. So those are just two practical applications of Vlookup, but it comes in handy quite often for engineering work because now we don't have to go into the table and look for these things. If we know what column to pull them from, we can begin to automate structural calculations and make the work we have to do by hand and the looking up we have to do manually much less, and speed up our calculations.